Group 1 elements are known as what? Alkali metal, whereas Group 2 elements are known as alkaline earth metal. As we move down the group from top to bottom, this ionization energy, which is also get decreases. During the hydration of the alkali metal, how much quantity of energy is released? That is referred as hydration enthalpy. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to deal with the new unit called S-block element. So before going to discuss with this unit, let's see the weightage first. Then we will understand what we are going to discuss in this session. Okay? So we can expect there is a 1 mark question, there is a 1 2 mark question, and there is a 1 3 mark question, and the total weightage of this unit is 6. Okay, and the question number will be goes like this. The question number 6, question number 14, question number 25 from this unit will be usually asked for your board, and there is a total weightage of 6 marks from this easiest unit. Okay, let's see what we are going to discuss in this session. So in this session, we are going to discuss with the introductory part of the S-block element, and we are going to discuss with the general electronic configuration of S-block elements, and we are going to discuss with the hydration enthalpy, ionization enthalpy, and atomic radii and ionic radii we are going to discuss, and we are going to discuss with the physical property. In that we are going to understand the flame test and density. So firstly, I'll go with the S-block elements now. So already we know that S-block element which comes in our periodic table on the left hand side, and the S-block elements are those in which last electron will be enters into the s orbital, hence it is named as S-block element, and the first and the second group in the periodic table, they are belonging to the S-block element. So hope you know this. This is a figure of the periodic table. You can see that this is a group 1 and this is a group 2. The group 1 and the group 2 element, they are together known as what? S-block element, and the element's name will be goes like this: lithium, sodium, potassium, rubidium, cesium and francium. And coming into the group 2, beryllium, magnesium, calcium, strontium, barium and radium. So these are the two sets of group 1 and group 2 element. They are together, it is known as S-block element. Why the name is given as S-block? Because the last electron which are enters into the s orbital, hence it is named as S-block element. So I'll explain that why that last electron will go to the s orbital in my electronic configuration. Okay, let's see with the first group element first. Okay, the first group elements are lithium, sodium, potassium, rubidium, cesium and francium. The group 1 elements, we know that these are known as alkali metals, whereas the group 2 element, that is beryllium, magnesium, calcium, strontium, barium and radium, they are known as alkaline earth metal. Group 1 elements are known as what? Alkali metal, whereas group 2 elements are known as alkaline earth metal. That is mainly because when these alkali metals, when it is reacted with the water, it forms oxides. Okay, that is why it will be strong alkaline nature, hence it is named as a alkali metal. So the elements of the group 1, they are called as alkali metal because these metal, they form a hydroxide when it is reacted with the water, and they are strongly alkaline in nature. Okay, that is why they are known as alkali metal. So hope you have understood that why they have given the alkali metal name for the group 1 element, because when they react with the water, it forms a strong alkali. The best example is the sodium when it is reacted with hydroxide, that is OH, it forms what? Sodium hydroxide. We know that sodium hydroxide is a base and it is strongly alkaline in nature. That is why this group of elements are known as what? Alkali metals. Coming into the general electronic configuration. Already I have explained that the S-block element which consists of group 1 and group 2, in these two groups, last electron will be enters into what? S orbital. That is why they are named as S-block element. So the general electronic configuration of S-block elements are noble gases NS 1 to 2, and general electronic configuration of alkali metal is noble gas 1 NS1, and for the alkaline earth metal is noble gases NS2. Okay, which indicates that the group 1 element which are having +1 oxidation state, whereas group 2 element they shows a +2 oxidation state. Because in the group 1 element their oxidation state will be +1, because in the outermost shell there is only one electron will be present. Whereas in the group 2 elements they shows the +2 oxidation state only because in their valence shell it consists of 2 electron. Hence it is named as alkaline earth metal and their oxidation state will be 2. So by knowing this general electronic configuration, we should understand about the occurrence of this alkali metals. Among alkali metal, sodium and potassium, they are very abundant, and lithium and rubidium and cesium, they have a lower abundance, and francium, which is highly radioactive in nature and it's a longest linked isotope, that is written as francium 223, and it has a half-life period of 21 minutes. Okay, and the alkaline earth metals, when it comes, the calcium, magnesium, which comes to the rank 4th and 6th in the abundance and in the earth crust. Especially the strontium and the barium, they have a lower abundances when it is compared with the beryllium, because it is rarely found in the earth crust, and radium, it is also a rarest element which is found in a earth crust. Especially the radium and francium, they are known as radioactive element. Okay, now let us see with the electronic configuration of first group 1 element. Okay, so what is the general electronic configuration for the group 1 element? It will be represented as noble gas N-1. We'll see with the elements which is belonging to the group 1 now. So the first member of this is lithium, which is having atomic number 3, and the electronic configuration will be written as helium 2s1, because the last electron you can see that it will enter to the s orbital. Similarly, for the sodium, it has symbol Na, atomic number is 11, and it is written as neon 3s1. Okay, the last electron which is enters to what? S orbital. Similarly, the potassium, the symbol is K, atomic number is 19, the electronic configuration will be argon 4s1. Similarly, rubidium, they are having the symbol of Rb and their atomic number will be 37, and electronic configuration will be krypton 5s1. Similarly, cesium, they are represented as Cs and their atomic number is 55, and the electronic configuration will be xenon 6s1. Okay. Similarly, the francium, which is represented as Fr, which is having 87 as their atomic number, and the electronic configuration will be radon 7s1. You can see that in all this element, the last electron which has enters to the s orbital and it having only one valency. Their oxidation state will be only 1. Why? Because in the outermost shell, it consists of only one electron, hence their valency was 1 and their oxidation state is also 1. So, hope you all understood with the general electronic configuration of group 1 elements. We'll see with the ionization enthalpy of the group 1 element. We all know that ionization enthalpy or ionization energy is nothing but a energy is required to remove the electron which is present in outermost shell of an atom. Is it right? When we talk about the group 1 element, we know that all group 1 element, they have only one electron in its outermost shell. Hence, the energy is required to remove the outermost electron is very easy in the group 1 element. After losing one electron, if you wanted to remove another electron from that element, the energy is required to remove the second electron, or we can say that the second ionization energy, group 1 element, it requires larger energy because all this element, they got a stable electronic configuration except the last electron. If you wanted to remove the last electron from that element, it is very difficult. So that is why the second ionization energy is very high in case of group 1 element when compared to the first ionization energy. So the first ionization energy of the alkali metal, they are lowest as it is compared with the element of other groups, and ionization energy of alkali metal decreases down the group. As we move down the group from top to bottom, this ionization energy which is also get decreases. Okay, and the reason is the size of the alkali metal, they become largest with respect to their parent. We know that as we move down the group, the size of the shells which is also get increased. As the number of shells which is increased, the energy is required to remove the second electron, that is also get increased. That is why, the second ionization energy in the alkali metal will be usually higher when it is compared to the first ionization energy. Only because the increasing in atomic size. Okay. Next is hydration enthalpy. So first we will see what is hydration enthalpy. Later we will understand what is a hydration enthalpy. Okay. Due to the increase in atomic size, hydration enthalpy of an alkali metal decreases down the group. Alkali metals, they can easily get ionized and extensively hydrated in aqueous solution. So when you take the alkali metal, if you dissolve in a water, it can easily give rise to the ions. Hence, this process of formation of ions in an aqueous solution, which is known as hydration. During this process, remember, some amount of energy will be released. That is known as enthalpy. So, during the hydration of the alkali metal, how much quantity of energy is released? That is referred as hydration enthalpy. When I talk about the alkali metals from the group 1, as we move down the group, this hydration enthalpy will be get decreased. Why it is decreased? Only because as we move down, number of shells will be get increased. Once the number of shell increases means, obviously, the ions, if you dissolve it in an aqueous solution, it does not give rise to any heat at all. Hence, this hydration energy will be decreases as we move down the group. So that is why I have written the order here. Lithium, then sodium, potassium, rubidium and cesium. They forms a very lesser ion when it is dissolved in aqueous solution due to the lesser hydration enthalpy as we move down the group. Next is atomic radii and ionic radii. We know that atomic radii in the sense it is the distance from the center of the nucleus to the outermost shell of an atom. Is it right? Yes. But as we move down the group, this atomic radii will be decreases. Why it is decreases? Only because of the increased number of shell. You can see here, lithium will be there, sodium will be there, and potassium will be there. You can count the number of shells here. 1 and 2 will be there. Here 1, 2, 3 shells will be there. Here 1, 2, 3, 4 shells will be there. As we move down the group, what will happen? Number of shell which is increased. As the number of shell which is increased, you know, the distance from the center of the nucleus to the outermost shell is also get increased. That is why this atomic radius will be usually it will be get increases as we move down the group, because as the number of shell which is increases, the distance from the center of the nucleus to the outermost shell will be increased, so that atomic radius which is also get increased. Okay, so you can take the example of lithium, sodium and potassium. So as we move down the group, number of shells will be increased. If number of shell which is increases means obviously their atomic radii which is also get increased. When I talk about the ionic radii, you know, on moving down the group, new shells are progressively added all through the nuclear energy which is increases down the group, but the effect of addition of new shell to the more prominent due to the increased screening effect of the electron and the inner shell. Hence the atomic radii will be increases down the group. Here you can see that I have written the atomic radii of the lithium, sodium, potassium and rubidium, and also I have written the ionic radii of the lithium, sodium, potassium and rubidium. You can see that this is a lithium atom. When it is loses one electron, you know, you can see that their ionic radii will be decreased as compared to the atomic radii. Similarly, when a sodium loses one electron, their ions will be get lost, so that ionic radii will be decreases from 1.86 to 0.96. Similarly, the potassium having 2.31 atomic radii, it has been decreases after losing one of the ion to 1.33. Similarly, the rubidium having atomic radii 2.44 will be get decreases to 1.48 only because of the removal of the ion. This is how we can easily understand that as we move down the group, atomic radii will be increases only because of the increased number of shell. When the number of shell is increases means automatically the distance from the center of the nucleus to the outermost shell will be also get increased. Okay. This explains the atomic radii and ionic radii in the group 1 element. Then comes to the physical properties of group 1 element. Alkali metals are usually silvery white solid. They usually what? Silvery white solid. But when you keep the solid outside, you know, when it is react with the atmospheric oxygen, they get tarnished because it undergo easier oxidation. Okay. And these are soft in nature. We can cut it with the help of knife except lithium. That is why the sodium and the potassium metal, they kept in a kerosene, and we can easily cut that metal by using a knife because these are very soft metal and they give a silvery solid appearance. When it is freshly cut, they have a bright luster and they are quickly faded because of the surface oxidation, and they are malleable and they are ductile also. The silvery lusters of the alkali metal is mainly due to the presence of mobile electrons. The presence of the mobile electrons in a S-block element which makes its appearance to be silver in nature. And being in only the single valence electron per atom, the metallic bond which is not so strong, hence the metals are usually soft in nature. So by learning the electronic configuration, we have understood that group 1 element, they have only one electron in their outermost shell. Since only one electron is available for bonding, they forms a very weak bonding with the other elements. Hence, these metals are usually soft in nature because of the very weak metallic bond. Okay. However, the softness will be increased in atomic number due to the continuous decreasing in metallic bond strength, which account for the increasing in atomic size. As we move down the group, what will happen to the atomic radii? It will be get increased because of the increased number of shell. Then is flame test. If you take an alkali metal and if you do the flame test, it gives a different colors. I'll explain you how it does give the different colors. Alkali metals and the salts which imparts the characteristics color to the flame. On heating the alkali metals or its salts, the electrons get excited easily to the higher energy level because of the absorption of energy. And this electron, in turn, when it is come back to the ground state, they emit the radiation in the form of radiation which fall into the visible region. That is why it imparts the characteristics color to the flame, and this property which makes the cesium and potassium to be useful in the electrode, especially in the photochemical cell. So here I have written some of the metal with their visible region, that is crimson red for the lithium which is observed on 670 lambda, and similarly for the sodium it is golden yellow which will be observed on 589.2 region. Similarly potassium will be observed at pale light, will be observed in the region of 766.5. Similarly the cesium which gives a sky blue color at 455.5 visible region. Okay. So you can see here I have given the pictures of lithium, sodium, potassium as well as with the rubidium. You can see that the lithium which gives rise to the crimson red color. Why it is giving crimson red color? Only because when you take such salts or when you take such metals, when it is holding in presence of heat, the electrons which is present in these metals, they get excited. When it is get excited, it will absorb some energy and come back to the virginal state. When it is come back to the virginal state, it emits some radiation. This radiation which is emitted by such electrons, it will be absorbed in a visible region. That is why we can see the characteristics colors in this alkali metal. That is why we can see the crimson red color when we hold the lithium salts. Similarly, we can expect the yellow flame in a sodium metal. Similarly, the violet flame in the potassium, and rubidium will give a red violet, whereas cesium which gives a violet flame. So, hope you know these things already you have done in your lab. Okay. Next, we'll move on to the last physical property, that is density. We all know that density is nothing but a mass by volume. Is it right? Yes. The atomic radii will be increases from lithium to cesium in the group, and the volume will be get increased. But the increase in atomic weight is more compared to that of the volume. Thereby, density will be increases from lithium to cesium. We will write that density as a mass by volume. Is it right? As the mass which is increases, what happens to the density? Density which is also get increased. That is why, as the mass increases from top to bottom, the density is also get increased. But we have exceptional cases. Taken on the example of sodium as well as with the potassium, the density of the sodium is more than that of the potassium. The only reason is we know that the density will be increases due to the increase in a mass. Is it right? But in case of sodium to the potassium atomic size will be more. Is it right? But sudden increase in a mass which makes its volume to become more. As the volume which is increases, remember the density will be decreases. This is the reason, when we compare the sodium with the potassium, sodium will have a more density as it is compared with the potassium, even though it has a increase in atomic mass. Okay, and we have an order of density, that is lithium, potassium, sodium, rubidium and cesium, which comes in this order. Okay, we have finished the introductory part of this unit, and in the next session we are going to discuss with the chemical properties of S-block element. So by this I like to say that what are all the things I have covered in this session, again it is very important for your NEET as well as for your CET. Have a look on it and try to make a note. We'll see with the chemical property in the next session. Till that, take care, be safe. Thank you.